Hello again, grade 12s. In this question, we first want to identify three similar triangles. After we've identified three similar triangles, we want to determine the value of x. In answering the first part of the question, what I would suggest you do if you're in a test or exam, identify angles that you can use as a starting point. So I will first label my angle R as theta. Now, if that is theta and you have a 90-degree angle within the triangle PSR, this angle here would be 90 degrees minus theta. Why is it 90 degrees minus theta? Because the sum of angles in a triangle add up to 180. Now, if this angle P was initially 90 degrees, that means the leftover angle here is theta. Angles on a straight line. You have QSR as your straight line. That means the angle at S here would be 90 degrees as well. Angle Q would be equal to 90 degrees minus theta. And that again is because of sum of angles in a triangle adding up to 180. Now that I've identified these angles within these triangles, I can now write down and identify my three similar triangles. So let us start off with the reference angle P, right? That's your 90 degrees. So if I look at triangle PQR, the angle at P is 90 degrees. The angle at Q is 90 degrees minus theta, and the angle at R is theta. Now this would be similar to triangle. Let us look at the medium-sized triangle. If we started off at 90 degrees, we need to identify another 90-degree angle there in the medium-sized triangle, and that would be S. We then went on to look at 90 degrees minus theta, and for the medium-sized triangle, we then go to P. We would then end off at angle R because that is your angle theta. This would then be similar to triangle SQP. You can see here again that the angle at S in the smallest triangle is 90 degrees, then Q is your 90 degrees minus theta, and your P is angle theta. There are several ways of answering part B. You want to determine the value of x. You could use Pythagoras' theorem and work out three equations for the smallest triangle, the medium-sized triangle, and the biggest triangle. Then you could manipulate those three equations to eliminate the unknowns by making them equal to each other. Then you would eventually get to your answer. But that's the long way. There is the shorter way where we would compare two triangles where we have the most values to work with. So let us look at the following triangles. I will highlight them for you. We will look at the smallest triangle, that is SQP, and we will look at the bigger triangle, PQR. We know that when you have similar triangles, the sides of those triangles would be in proportion. So based on that, we can set up the two ratios as follows. PQ divided by QR, and this is referring to the bigger triangle, would be equal to the ratio of the sides SQ divided by QP. We know what PQ is, right? QP or PQ is equal to x. QR is equal to 16. And SQ is equal to 4. And QP, again, is equal to x. Why were we able to do this? We were able to do this because triangle PQR is similar to triangle SQP. Remember, we showed that in the first question. We can now cross multiply. X squared would be equal to 4 times 16, which would then be equal to x is equal to 8.